Here we have a couple of examples of limits that have radicals in the denominator. Let's take a look at part A. We have the limit as x goes to a of x squared minus a squared all over the quantity rad x minus rad a. So first, let's just note what would happen if we plug straight in. Since this is going to a, what happens if we just plug in x for a? Note if we did that, we'd get 0 over 0, which is what we call an indeterminate form, which means we have to do more work here. One of the best tricks in all of Calculus 1 and Calculus 2 is what's known as the conjugate trick, which we'll use here. It's super useful when you have a radical that's giving you a hard time. And the conjugate of rad x minus rad a, or square root of x minus square root of a, if that's how you're used to hearing it, is, well, you essentially change the sign between the two terms. That's what the conjugate always is. So it's a negative, so we'll change it to a plus. So we multiply by the square root of x now plus the square root of a, and then you have to do the same thing on the top, right? Because we're just multiplying by 1 here. Make that square root of x plus square root of a, all right? So you want to do the exact same thing on the top and the bottom because we're really just multiplying by 1. Okay, what does that do for us? Well, let's see what happens. It makes the numerator a lot worse. We can be honest about that. Now up top we have, let's rewrite our limit. This is still a limit. X goes to a. You have to keep writing that until you evaluate the limit. X squared minus a squared times the square root of x plus square root of a. Okay, but on the bottom, look what happens. If we FOIL this together, our first term is rad x times rad x, which is simply x. And then the outside and inside will cancel out in the FOIL process. That will always happen if you're doing this conjugate trick correctly. So the outside and inside cancel in the FOIL process. Then we get minus square root of a squared, which is a. And let me just note, actually, for this problem to be completely accurate, we'd have to say a greater than 0. I think the way it's stated in the book, it does say that, just so we're not getting stuck in arbitrary imaginary numbers there. So that's just one little restriction we'll put on there. Where can we go from here? Well, one thing we can't do is cancel this x with one of these x's up here and this a like that. You can't do that. What you can do instead is factor x squared minus a squared. So let's do that. Here we have, okay, the limit as x goes to a, and now x squared minus a squared becomes x plus a, x minus a, and then look at that. Okay, we still have the square root of x plus square root of a hanging out over here, all over x minus a, and there is the cancellation we were hoping for. You should get some cancellation like this anytime you're doing the conjugate trick. If you don't get it, maybe go back and check and see if you didn't make it wrong turn somewhere along the way. Okay, this leaves us with the limit as x goes to a of something a little bit nicer. We have x plus a times square root of x plus square root of a. And now let's see what happens if we just plug in a for x. We certainly won't get 0 over 0 anymore. Instead we get, okay, so we have a plus a times the square root of a plus the square root of a. Simplify this down, we get 2a times 2 square root of a. Okay, good old arithmetic here. So that's 4 times a rad a. Well, this is a times a to the 1/2. Add those exponents. You get 4a to the 1 plus 1/2 is 3/2. And there we have evaluated the limit. This conjugate trick shows up again and again. It's one of the more useful tools in mathematics. So make sure you have it down and you're able to use it. In fact, why don't you try part B on your own? Pause the video. Let's read it out. We have the limit as x goes to 1 of x minus 1 divided by the quantity rad 4x plus 5 minus 3. So pause the video, see if you can use the conjugate trick to evaluate that limit. This is exactly the kind of limit I could imagine showing up on a calculus final exam, for instance. And then we'll compare notes after you've tried it yourself. Okay, let's try it together. So here we go with our conjugate trick again. We have our conjugate rad 4x plus 5. Now it was minus 3, so I'll write plus 3. That's the conjugate part, right? We do it with the opposite sign. So it was minus, it went to plus. And now we duplicate that exact same thing up here in the numerator. 4x plus 5, rad 4x plus 5, and then plus 3 again. Okay, so next we can put parentheses around these just to keep everything straight. We essentially have a binomial times a binomial on the top and a binomial times a binomial on the bottom. Things can get messier before they get cleaner. So let's see what happens here, but let's not lose track of what's going on. So we have the limit as x goes to 1. I'm just going to leave these top two separated because I'm hoping something cancels out. So I'm going to leave that as x minus 1 times the square root of 4x plus 5, all plus 3. That's going to hang out. On the bottom, though, when I FOIL these together, our first and first, so I'm looking at rad 4x plus 5 times rad 4x plus 5. We multiply those together. All that happens is the square root sign vanishes. So we have 4x plus 5 by itself on the bottom. Now we're essentially foiling these together, so we do outside and inside, and note that those cancel. They're exactly the same, except for one of them is positive, one of them is negative. So those two will cancel out. Feel free to write those out if you want. And then for last, as our FOIL, we have minus 3 and plus 3. So that's going to be minus 9. And then look, we can really work this out in the denominator here. So let's see what happens. So our denominator then becomes 4x, let's see, 5 minus 9 is minus 4. Well, I'm going to factor a 4 out of that. We have 4 times x minus 1, the quantity x minus 1. Look at that. And now note that we also have an x minus 1 up in the top, in the numerator there. So those will cancel out. So let's clean this up. Starting to get a little chaotic out here. So we have the limit still as x goes to 1. We haven't evaluated the limit yet, so we keep writing it until we evaluate it, and then we stop writing limit. So we have 4x plus 5 under the radical, and then plus 3 outside the radical, all over 4. And now let's try evaluating that limit again. Oh, I guess I forgot. Right in the first step, if you evaluate the limit right off the bat, note that you would get 0 over 0 indeterminate form. Well, now if we plug in 1 for x, we have something we can work with. We have square root of, what is that, 9 plus 3 outside the radical, all over 4. Well, square root of 9 is 3. 3 plus 3 is 6 fourths. So how about simplifying that down to 3 halves? Hopefully that's what you got as well. If you didn't get that, I recommend making a note of that somewhere and going back and reworking this, because this is definitely the kind of exercise that you want to have down cold. Not just for the exams and the final exams and all that, but also because this method is so useful, you'll see it again and again. So it's good to get the method down now so that you can use it moving forward.